Let's evaluate a logarithmic function. First, let's kind of think about a logarithmic function, what it is and how we play with it. So if we're going to evaluate it, we have some steps. So first, we're going to rewrite it as an exponential function. So we're going to have to talk about the relationship between a logarithmic function and an exponential function. Once we rewrite it, then we can solve or evaluate that exponential function. The big key is that we need to make sure we check for restrictions because logarithms have certain stipulations that must be met. So after you find your answer, you have to go back and say, does this meet all of the stipulations? If yes, then great. Okay, so remember, if b to the y equals x, then y equals the log of x base b. How I remember this. B is the base of the exponent. B is the base of the logarithm. So the base is the same. Now, I remember things in a not so mathematical way in that I say, okay, with the exponential, the y is with the base b. And it can't be the same both ways. So if y is with the base b in the exponent, then x gets to be with the base b in the logarithm. And you can also think of it, I like to do this way. Let me get a different color here. I like to say b to the y equals x. And sometimes if you are a visual person, drawing these big whoopy, swoopy things can be helpful. So, okay, let's play with these. Let's find the value of the log of x base 3 equals 4. Okay, so doing the big whoopy thing, we got the 3. 3 is the base of the logarithm, so it's going to become the base of the exponent. So 3 to the 4th power equals x, right? So you kind of go in a circle. Now, 3 to the 4th power, that's just simplifying this, and 3 to the 4th is, in fact, 81. So we would say the log of 81 base 3 equals 4. Now, to talk about the stipulations, remember that the argument of a logarithm must be, that's not what I wanted. I don't know why I put a b there. This must be greater than 0. It's got to be positive. And the base must be greater than 0. That's an argument. Okay, so both of these must be positive numbers. One's a 3, one's an 81. So this is golden. 81 is my answer. Now let's look at the second one. Find the value of x. Log of 49 base x equals 2. Okay, so I start with the base. Base to the second equals, do your swoopy, 49. Now, x squared equals 49. You can do this a couple ways. One, you can say what squared is 49. Or you can say, well, if I square root both sides, then x is plus or minus 7. Because 7 times 7 is 49, and negative 7 times negative 7 is 49. So we think there are two answers. Okay, now if you look up here and say the log of 49 base 7 is 2, positive, positive, okay, so that works. And then if we would say log of 49 base negative 7 is 2, base is negative. That is no good. So negative 7, that's the restriction piece. So our only answer is x equals 7. Let's do one more. Log of 64 base 4 equals x. So again, we start with our base of 4. 4 to the x, swing back around, is 64. So now you might be thinking, well, if you don't know your higher powers, you can say, okay, 4 to the first power is 4. 4 squared is 16. 4 to the third is 64. And therefore, x equals 3. And this one, the argument and the base are both given, both positive. So we are golden there. Evaluating logarithmic functions.